Yeah, hello everyone. Myself Maruti, welcoming you all to this math video session. So, in this video, I'm going to explain regarding a sum related from real numbers. Little bit tricky concept, but I'm sure that I can make you sit in. Okay, so here the concept is explain why 7 into 11 into 13 plus 13. I check it out. 7 into 13, 11 into 13 plus 13 and 7 into and so on plus 5. Why they are composite numbers? What's the reason? How can you say they are composite number? This is the sum from real numbers. So let's take, he has given two separate numbers we have to work on and we have to explain why they are composite numbers. So let's work on. So given numbers, let us take both the numbers, given numbers, whatever are the numbers, let us take it. Given numbers, right? The first one is 7 into 11 into 13 plus 13. That is the first one. Okay, that is the first one. And the other one is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. These are the two numbers what we have given. Okay, so my plan is, let's consider the first one as x1 and the second one as x2. Let this one I like to call it as x1. 7 into 11 into 13 plus 13, I like to call that one as x1. Now there is one more number here, I like to call this one as x2. 7 into 6 into 5 into 4 into 3, 2, 1 plus 5. So I am considering this one as x1 and I am considering this one as x2. Now if you check it out properly, so the plus what is present here, right, the 13 and the 13 present here, I think I can take them as common. So x1 I like to take it here itself, I like to take 13 as common. Okay, if I take 13 outside, what is left over? Can I call it as 7 into 11 plus 1? Why? Because I took 13 as common. Now here, if you check it out in this question, so it's x2 is nothing but, if you check it out here, 5 and 5, I can take it as common. So I'm taking 5 out. So what is left over inside? 7 into 6 into 4, 3, 2, 1 plus 1. There we go. There we go. So now the same, I can write this as 13. Okay, 7 11s, it's nothing but 77 plus 1. If you simplify that, it's nothing but 13 into, it's nothing but 78. Okay, so I got that as 13 into 78. Now if you go for this side, x2 is equal to 5 into, if you check it out, I am sure if you multiply all this stuff, it's nothing but 1008. Right, if you multiply 7 into 6, 4 and so on, you'll be getting it as 1008. Now, if you check it out, x2 is equal to 5 into, it's nothing but 1009. Okay, we are done till here. So now I am writing x1 as 13 into 78 and x2 as 5 into 1009. Okay, now there is one more trick here. What I am doing, I am writing the 78, I am prime factorizing that. So prime factorizing, right, prime factorizing what the number present over there. So 78, if you prime factorize, if you start with the 2, it's nothing but 39, and if you take with 3, it's 13. So 78 can be written as 2 into 3 into 13. You got that one? So 78, 2 into 3 into 13. I like to plug in there. So 13 into, what is 78? 2 into 3 into, it's 13. So what I have done, the 78 present here, it has been prime factorized. So if you check it out, it's nothing but 2 into 3 into, shall I call it as 13 square? Yeah. So now x1 is nothing but 2 into 3 into 13 square. Now if you check it out, if I consider this one as, is it a prime number? Yes. Is it also a prime number? Yes. And is this also a prime number? Yes. How many prime numbers are there? So P1, P2, P3. Now let us recalculate what is a composite number. Right, what is a composite number? So let me write the definition for you. According to the fundamental theorem, right, according to the fundamental theorem of arithmetic, what is a composite number? What is a composite number? So what's a composite number? According to the fundamental theorem of arithmetic, a composite number, right, a composite number can be written as the product of, right, a composite number can be written as the product of unique primes. Right, this is what the definition of a composite number according to fundamental theorem of arithmetic. What is saying? What is a composite number? Here, if I take x1, right, is it the product of the prime numbers? Check it out. So is it a prime? Yes. Is it a prime? Yes. Is it a prime? Yes. So the composite number x1 is able to be written as the product of prime numbers, right? As the composite number x1 is able to be written as the product of prime numbers, then yes, according to the fundamental theorem of arithmetics, yes, the number whatever is given is a composite number. If you check it out, and here, what is the meaning of the word unique? What's the meaning of the word unique? Means it has its own style, right? It is unique. No other composite number can be written in the form of this. That's what I mean. What is the meaning of unique? No other composite number except this number, no other number can be written as the product of 2 into 3 into 13 square. Of course, order may vary. Order we can change it. We can write it as 3 into 2 into 13 square, something. We can shift the order. But no other composite number can be written in this form. So as x1 is satisfying the condition that it is written as the product of unique primes, I can say the x1 is a composite number. So of course you have to remember these primes are written in the ascending order, means P1 is less than P2 is less than P3 and so on. It might be Pn. All the prime numbers, they are written in the increasing order. So according to the definition of fundamental theorem of arithmetics, what I am saying, as the number is written as the product of unique factors, all are prime numbers and it has its own style. Therefore, this is a composite number. Now let's get back to this one. So 1009. So is it a prime number? Yes. Is it a prime number? Yes. P1 and P2 is written as the product of unique primes. Therefore, the number x2 is also a composite number. According to what? According to the fundamental theorem of arithmetics. Hope you are able to understand. In this channel, I have been placing both math and science videos.